Now let's look at adding and subtracting rational expressions. We'll look at a couple of numeric examples and then a couple of algebraic examples and show the connection between the two. We've done this a lot in the past in prior math courses. So we know that whenever you're adding and subtracting fractions, you have to have the denominators equal in order to add or subtract your tops or your numerators, so that you're dealing with the same amount of slices of the pie. I guess if you think about it in a pizza form, or this is parts of the whole, right? So how many slices before you can compare? They have to be apples with apples, same kind of thing. So if I have this 1 over 12 plus 7 over 12, cool, the denominator is the same, so I can write them over that denominator. 1 plus 7 is 8. Now, we would never answer that. We're looking for one answer that everybody will get, the simplest form we're always looking for, any kind of fraction like that. So it's a unified one answer. So when I ask you for the answer something like this, you would give me this in reduced fraction form. Divide 4 out of each of them, or that's 4 times 2 and that's 4 times 3. And you should get 2 over 3. So 2/3 is what you give me for an answer for that one. Now we're going to do the same thing, except for the bummer is we do not have the same denominator in this one. So that means I have to write them both over the LCD. So in order to do that, I have to find the LCD of each. One quick way to do it when you're dealing with kind of smaller numbers, you can also do it with prime factorization tree, but a cool quick way to do it with these, I take the larger number, multiply it by 1, then see if the smaller number goes into it. 4 does not go into 10. And then multiply it by 2, and then so forth, all the way down to your natural numbers. So 4 does go into 20, so 20 will be the LCD. So I'll write it as 20 and 20. Multiply what did you have to do to this denominator to make it a 20? We have to write the equivalent fraction in different forms. So what I had to do was multiply it by a 5. So what you do to the bottom, you do the exact same thing to the top. So you do not change the value of this, just the form. So I should end up with a 35 on top here. Same thing now when I subtract this, I had to multiply this one by a 2, so multiply the top by a 2, and you should end up with a 6. Now they're the same denominators, I can write that answer over that denominator. 35 minus 6, I should get 29. There are no common factors. 29 is a prime number, in fact, and so I would generally, in algebra classes, we generally avoid writing a mixed number because it looks like multiplication, unless it's like an application problem, and that would make sense. So I would leave it as an improper fraction form, 29 over 20. Now, the next one will be some algebra versions of the same stuff. So if I look at something like this, cool, denominator is the same. So same process. This is x squared minus 4. On the top, I should have x minus 2. Now, I think, okay, cool, that's my answer, I'm done. No, you're not. Now, when we're adding and subtracting fractions, if you noticed, once you added or subtracted, you always factor and cancel at the end. So that's the difference of the multiply divide. Multiply divide, we factor right off the bat everything in the multiplication ones, and then we cancel, and then multiply straight across. In the add or subtract, you do your adding and subtracting. First, you have to make the denominator the same if need be, and then you do that. But then you always have to reduce your answer at the end. So factor and cancel. So remember that. Now notice I can't cancel these x's because they're not products. Things have to be multiplied in order to cancel. So be careful. I'll see that a lot. Oftentimes people want to cancel like the 2 and the 4. Can't do it. They're not multiplied. That's all one term in itself. But this is the difference 2 squares right here. And then I have an x minus 2 up here. Those cancel right there, the whole x minus 2. So now I know my answer is 1 over, because everything's gone on the top, so it's 1 over x plus 2. Another common mistake I'll see is people will give me x plus 2 for an answer like that, but no, we actually did do some canceling. I mean, there is, the top is gone. X plus 2 would be a way different answer, right? It's still in the denominator, so this is 1 over x plus 2. Now this one, a little bit trickier. I look at this and I go, man, well, the denominators are not the same. And we did subtraction on this one. It's okay, subtraction and addition, you treat the same. You have to be careful if there is more than one term, you may have to distribute. But on this right here, I am going to find that LCD, just like I did over there. Well, in this case, they're both relatively prime to each other. There's no common factors. They're already factored themselves. So the LCD is actually just going to be both of them multiplied together. Like if I had 2 and 5, it would just be those two multiplied together, it would be 10. Because they're relatively prime to each other. They're both factored and they don't have a common factors at all. And then this is going to be an x minus 1 times x plus 3. So that's the LCD. I'm going to write them both over the LCD, but now I have to figure out what did I have to multiply this one by to make it that. You're just missing the x plus 3. So you have to do to the top and the bottom. On this one, I'm missing the x minus 1. So let's do it to the top and the bottom. And then I can distribute, right? The reason is you have to include everything before you can factor these things. So I'm going to distribute that through and say it's 3x plus 9 plus 5x minus 5. So multiply those two together. Now we can write them all as one fraction. X minus 1 times x plus 3. Combine my like terms or just add these. Combining them would be, it's not a minus, I don't have to do distributive of the negative, so I'd end up with 8x's. It looks like plus 4. Now I do notice there is a GCF. Always look for factoring at the end. There is a GCF I could take out of a 2, or I'm sorry, of a 4. And then I would be left with 2x plus 1. But 2x plus 1 is not a factor of the denominator and it would not cancel anything. So I'm going to have it to just factor it anyways, just to check. But I noticed there is nothing, so this would be a correct final answer.